Aloha everyone and welcome to another video by me, K. Elmer, and in this video I have got the absolute most amazing discussion with Hank Sanders, who's a master tinker. That's my interpretation, because he is the first person that I've ever heard about and have the honor to be able to just sit and chat with, who actually decided to build his own C60 arc reactor to make C60 powder. That is something that's unheard of. Normally, the only individuals that even try to do something like that is government or academics or businesses. And so here's an individual who has a machine shop in his house, a deeply understanding wife, and and he decided to build himself a C60 arc reactor. And you know what's even more important? This guy is such a great guy. He's decided to share his experience with other people. And I just can't say how amazed I am that anyone would do this. And once you listen to this, you'll understand how incredibly complicated it is. It's quite dangerous as well. But he's pulled it together, and not just him, but his team of friends and family. It's an amazing story. In the C60 world, this is unbelievable. So, and and he did it. Today he did his first test firing. There's a video of that here coming up, and so today I asked him, hey, let's do a webinar. Let's talk about this. People are going to find this interesting because nobody else ever tried this before. It's the first time. So just absolutely, I'm amazed. I had a great chat with him, and I'm here to share that with you. And again, I just want to say, thank you, Hank, so much. Thank you for your time today. Thank you for all the people who participated in our webinar. You can find Hank if you have questions after after the webinar. He's in. We have our own, actually. We talk about. I talk about our Telegram chat groups a lot in my other videos, but there's actually an extra room. There's different rooms for different topics. One is called Build Info, and that's the one that Hank and I started just to talk about what it would take to build an arc reactor. And you can find him there. His handle there is at henpeck21, and you can find him there. And there'll be a link in the video description to how to join that chat room. So again, thank you very much, Hank. Awesome discussion. Loved it. Thank you so much for your time. Congratulations to you and your team to pull this off. I mean, seriously, this is amazing stuff. So mahalo. Thank you. And please, everyone, enjoy the webinar, enjoy the discussion, and thanks for stopping by. Aloha. Well, there we go. Welcome everybody who's joined us. This is a new series, I guess. I'm doing webinars now. Yeah, I don't know. But hey, I just want to say thank you for joining the webinar. I want to just introduce our guest speaker today. Is Hank Sanders, who is a brilliant tinker, who has taken it upon himself, and with a team of incredibly bright people, talented people, who have literally you're the first actual non-business kind of, like, just build it in your garage, built and it's on the screen right now. I'm going to go ahead and share my screen so you can kind of see the pictures that Hank sent me. A C60 arc reactor to produce C60. And for those of you who are going to watch this on YouTube later on, I just want to preface this with the concept that, to me, this is modern day gold mining. And the reason I say that is because the current retail price for C60 right now is anywhere from $100 to $245 a gram. And so if you look at the current price of gold today, it's about $47 a gram. So you are looking at a substance that costs 2 to 4 times or 5 times as much as gold. And it is literally gold mining. It is C60 synthesis, and Hank Sanders is you built one in your garage. I'm sorry, that just blows my mind that anyone would be able to do that. And as I said earlier, Hank has done something that no one outside of government or academia has done, which is actually do this himself and with his team. And so I just want to say, welcome, Hank. Let's talk about your build.
Yeah, I'm thrilled, man, and it's really good to talk to you. We were bored around here one Saturday and figured we didn't have anything to do, so we built the reactor.
Yeah, you're crazy. Okay, so yeah, I just want to preface that Hank and I have been friends for years, and I just want to say if you have any questions, please put them in the chat box at the bottom of your GoToMeeting dashboard, and I'll be looking at those questions already. I've actually given Hank a full page of questions and things, so let's just go ahead and just jump right in, Hank, and um, go ahead. It shows yours, and
Absolutely.
I'll just moderate.
Well, all right. Well, the very first question was, how did we get into building the reactor? And actually, it's a really fun story. Back Christmas 2 years ago, my father was going to lose his driver's license because he had to have eye surgery. He had serious issues, cataracts, that sort of thing. And we had heard about C60, so we had literally just a couple of months before that started taking it. So when I found out about a situation where he was going to have surgery and he wasn't going to be able to drive, I went up there literally about 2 weeks before Christmas, and I said, "We're going to give you your Christmas present now." Well, he started taking it, and within 2 months, automatically, his optometrist said, "I don't know what you're doing, but it's not really possible in your situation that you can be improving your eyesight, but whatever you're doing, keep doing it." And of
Cool.
course, he's talking to him, and he's telling him, "Well, we're taking CC." He's like, "I don't need to know that."
Yeah,
He
they
said, "I
never
can't
want
tell
to
you to
know.
take it or
Yeah,
not."
yeah, they never want to know.
Yeah. So that's kind of what spurred it. And then we had some other issues. We got some dear friends that have had some cancer issues, and that's been kind of popping up in the family. So that was really kind of the drive. It was simply that we knew that it worked, and it worked really well for us. And it got to a point where we could almost never source it, and even if we could, it was so hard to get and to be able to afford it. So that's really where this went.
Okay, that's so you decided to make your own C60 and instead of just buying some product or buying the powder, that
Well, at the time you
just
couldn't.
jumped both feet in. Okay, all right, all right.
Yeah, no, really. I mean, at the
That's
time
crazy,
you
but yeah,
really
that's
couldn't.
cool.
Um, as we progressed in this, and please understand this, it's I appreciate it, and I'm not flattered, but this is not me. Uh, my father has put a tremendous amount of effort into it. We've got several friends that have worked on it. My wife has just been incredible through this whole thing. I mean, bless her heart. We're always talking. I say things like, "In this regard, you did not choose wisely." She's like, "Shut up."
Yeah, well, I remember when you first told me you wanted to do it, and then your wife made you move it out of the garage into the shop or something farther away from the house. Once she figured out that thing burns at the heat of the sun.
Yeah, that was awesome. She's like, "Seriously?" I'm like, "Well, it might be slightly over exaggerated, but and of course it probably was under exaggerated." But no, we were actually on vacation in Florida and I will never forget. And I typed in those lines. Okay, I think we may just have the resources and the ability to pull this one off.
Oh, you're breaking up. We're not hearing you right now. Can you hear us still?
Still there?
Okay, gotcha. You're back. Okay, you're not back now. Oh, shoot. Yeah, I can't hear you, Hank. Still can't hear you. Oh, shoots.
Can you hear me?
Yes, right now. I can hear you now.
You cannot hear me?
Yep, I can hear you. Sound good.
Okay, for some reason, all my audio just cut out. Vicky, I've got no idea what's going on. However,
We can
my
hear you.
wife is listening on her phone at the moment, so
Yeah, we
we'll
can hear
just
you.
work around.
Okay, keep talking. We got you.
Where did we? Oh, yeah, in Florida, and yeah, big mistake.
Okay. So why, like, when you were like thinking this through, why do an arc reactor and maybe not another method like, laser ablation, chemical, I mean, there's different ways to synthesize C60. I mean, I know that you did a lot of research, so I mean, how did you come about like picking this was the type of reactor you wanted to buy or to build?
Well, It really wasn't when we first started. The reactor actually is very versatile, and you could use it to burn in several different ways. Originally, I had considered doing rod, but what I really wanted to do was plasma.
Okay.
Uh, However, the problem that I ran into with plasma was that when you're doing plasma, you have to supply approximately, depending on your model and a few other things, 32 CFM in. Then you still have to be able to achieve a 6 or 700 torr vacuum in the thing. So that means that you're having to suck gases out of this thing that I mean, I'm not sure what vacuum pump could keep up with that. You're going to have a complete and entire cooling system. That would be a really, really big machine. And I've not given up on that. I do plan to look into that later. But the simple way to do it, although I hate it, is just to burn rods.
Huh. Okay. Yeah, I can imagine the heat of that gas coming out. Just that alone would melt everything.
Exactly.
Right. Yeah. Okay. All right. So simplest design is the arc reactor.
Correct.
And then
Tried
so
and true.
yeah. So how much did you know about, I know that I have a machine shop, so obviously you can weld and do all that stuff, but how much did you know about this before you actually started?
None.
Really? You just started with
No, from the conversations we had in the
yeah,
talk groups in
yeah.
the past, I had a pretty good grip on it. But what really got me was when we got into the files from the Department of Naval Research.
Okay.
And that's pretty much where we based our machine on.
Oh, okay. All right. Yeah. So I've seen that. I've read all that stuff. I have a whole directory
Hmm.
full of papers about how to build these things and run them and stuff like that. It's fascinating information. I was going to try to do a video on it one day, but it's just it's on the list. Okay, okay.
Well, yeah, I'm starting on it right now because it's
Yeah, that's why
basically the
I'll
same
just
thing.
have you talk about it. It's so much easier. So, so you read those documents or the studies or the write ups about it, and so is that where you got your design, or did you create your own design as you went? Kind of figured it out by yourself.
Well, I basically used their same design, but as you're doing this, you're thinking, well, that was stupid. Why did they do this? Or and later when you get into your builds, you're kind of like, okay, well, now I understand why they did that.
Oh, okay, all right. So, um, the in terms of just like the design, I don't know if you had a chance to hear the previous webinar where Martin had kind of
I
talked
did.
about his design was based on basic universal properties or principles. And in my
Hmm.
mind, my interpretation when someone says that is doing things along the standards of the golden mean, the Fibonacci's and those kinds of like design elements where you would size certain things a certain way, flow things a certain way, like Schlauberger, Victor Schlauberger's his all
Hmm.
of his concepts on how energy and water flow. And did that have any play into what you were into your design? Because I guess we're looking at it right now. If you look at your screen, this is it, right? This is the whole thing, or because I've just got a bunch of pictures from you this morning, so I'm assuming this thing in front of us is the arc reactor open.
Yeah, yes, it is. And
Okay,
if you flip down through the pictures,
sure.
you will see different angles and views.
Okay,
And I'll be glad to explain what all of it is and how it works. That's not a problem.
okay. Well, I'll tell you what. Let's go ahead. Let me just start at the top. The
Hmm.
first picture about what the machine looks like. There's you playing with it, and then how about let's start here, and then yeah, why don't you just could you just because I've never seen this until this morning, so just yeah, if you just like what are we looking at, and just kind of explain that.
Okay, back up about two or three pictures.
All right, I'm just going like to the top. That's the top of the list right there.
Okay, keep going. That's just a vacuum system.
Okay, just let me know when to stop.
I will. Okay, right there.
Okay, right here. Back up.
All right, so what you're looking at right there on the left hand is an end cap or a head, and what's built onto it is actually a water jacket.
Is that this part right here?
No,
Oh,
circular on the bottom left.
okay.
Okay, so that would be the head, and if you go
Okay,
towards the center where the orifice is,
right. This.
okay, that's actually a water jacket.
Oh, okay. What is it?
And if you go a couple forward, keep going. Uh, I didn't. mean for that one to be in there necessarily. Okay,
Oh,
now I'll back up a little bit.
oh, okay.
Now that was a second build.
This,
Going.
this.
Yeah, that's the second build.
Oh, you did a second one? Oh, you're. Oh,
Yeah.
it's right. You piloted. Okay, okay. Okay. So, do I have the picture you're looking for?
Mm-mm. No, keep going. Other direction. Very back up to the top.
Okay.
Okay, okay, wait.
All right.
Go
Sorry.
forward just a little bit. Okay. If you'll notice, you've got water going in one side of that water jacket, coming out the other, okay?
Mm-hmm.
All right, now what it's connecting to in the middle is also a water jacket. So you have an interior skin for the burn chamber. You have an exterior skin as a water jacket.
Okay. All right. Like a car. Right.
Exactly.
Yeah. Okay.
So it's constantly circulating water both through the water jacket, around the burn chamber, and on either one of the heads. So it's fully water jacketed.
How do you keep the water cold?
Well, right now we put it outside.
Oh, okay. Oh, it's right.
No, it's all relative. When you
Okay.
start
Yeah.
talking about this stuff, it's not necessarily hot or cold. It's only variations in temperature.
Oh, okay. All right. All right. Cool. So let's go. Let's just. Okay. So let me just. And then I'm just gonna. This is basically okay. I'm just gonna. You want to just. You want me to flip through the
That
pictures
was
and?
that water jacket being fabricated right there.
Okay. All right. Okay. Cool.
So it's completely hollow. We had to mill out the centerpiece. We had to cut down the pipe, put it in place, weld it up, and there you go. Then we had to put a core through the center, and that's how we get it.
Okay. So and then right here, this picture is what? What is this thing? That's your.
That is a
What is it? Like a
very
pump?
lightweight vacuum system.
Oh yeah. Yeah.
Really, it's only for testing at this point.
Oh, okay.
Anybody who wants to build one of these things, you need to be looking at a gas vacuum motor.
Okay. That's right. Okay, you know what you mentioned to me while we were chatting before, but maybe I think it'd be very helpful for folks listening in that you built two. You built a test one, right? So before you built the
Well,
final
we
one, right?
collectively we have built two. We built one with a full water jacket
Uh-huh.
and one that did not have one. Now, scroll through the pictures a little bit.
Okay.
Keep going.
There's
Keep going. And I would love to do this myself, but as you know, I'm inept with a computer.
yeah, no problem. I'm more than happy to sub. Okay. Uh, okay. So
Okay, there you go. So that one we nicknamed Skinny, and that one does not have a water jacket.
okay.
So that actually happens inside a water bath.
Oh, okay. All right. And how did that one
Now,
work?
okay, honestly, uh, the build was never finished.
Okay. So what? So you gave up on skinny and went to fat boy? Oh wow, we're talking like you're extreme. Oh
No,
no.
one's skinny and one's
Okay.
tiny.
Bad analogy.
Uh, no, the problem with Skinny that we ran into right at the very end of the build, we had a welder go bad,
Oh, okay.
and we were not aware of it. And by the time we realized where we were at, it was just irretrievable.
Oh, wow. Okay, that was okay. Lesson learned, right? The
Exactly.
tools need to be as good as as everything else. Okay, well that's
Well,
lessons learned.
no, actually, now that you say that, this is one of those things. And again, just for people who want to try this, TIG, 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 TIG. That's it. No stick, no MIG, not TIG.
Okay.
And whoever you have weld this needs to know their business. 303 and 304 is very, very hard to work with.
So that's the type of steel that you used for all of the different components.
That is correct. 303 and 304 stainless steel. Yes.
Does it matter?
303 and 304 stainless steel
Uh-huh.
has a working temperature up to about 1500 degrees. After that, it's going to start to lose its, oh gosh, you'll start to get rust spots, things like that. It won't maintain being stainless
Uh-huh.
past 1500.
Okay. Okay, I tell you what, let's just okay, so if you could, let's just because this is what I'm real interested in. Okay, so this was your first vacuum pump. This was your making the water jet. that you set in your
Mhm.
garage on fire.
No,
Okay.
actually, that's a good friend of mine, Todd. He'd known him my entire life. Great welder.
So everybody just chipped in and said, "This is cool. Let's see what we can do."
Yeah, pretty
That's
much. I
awesome.
mean,
Okay.
basically, all I contributed was I read a lot, thought a lot about it, and I'm like, hey, you go do that.
Okay, cool. Okay, so this is what it looks like. Now, is this what it looks like assembled? But it looks like there's still stuff not plugged in or connected. So, but this
Yes,
is
no, it is not, because at
okay.
this point we're just doing dry test burns.
Oh, okay, okay, all right. So this is where the water comes in. It goes into a container, and then inside the container, you've got your arc, your rods, right? And then this is what it looks like from the side. So, and then what's the
Well,
thing
you
weigh
know what?
anyway?
Don't tease. Go ahead and show the video.
Oh, okay. I was going to save that for last, but
Yeah,
okay.
I know, but I couldn't help it.
Okay, so this is cell phone video. So is this an appropriate size? I don't think it's going to get much better, but okay. So here we
Yeah,
go.
and it's really low quality. I apologize for that.
Oh, no worries. Okay, so here we go. This is the test burn from this morning, right?
That is correct.
Cool.
Brother, it is hot.
So what did you put up against it to get it to light up?
uh, Actually, we're just using a standard arc welder, which is
Oh,
what they used back in the Department of Naval Research. I mean, it's easy, it's simple. I do not have the infeed set up on that yet. It's going to have an automatic infeed on it.
okay. So this right here, I'm just is whoops. Okay, so the actual thing that was glowing right here. Whoop,
That
let me just go ahead.
those were the carbon rods.
Okay. So you're using carbon or graphite?
That kind of depends on who you ask.
Oh, okay.
There are a lot of people that think it's the same thing. We're using graphite, actually.
Oh, okay. So you would put your graphite rod on the inside of this chamber surrounded by water, and then on the outside of this chamber is where you actually, right there, this is the, I guess, I mean,
Right.
is there a
You would
difference
put your
between,
infeed there.
like cathode and anode? I thought there would be like a space between, like you'd have a cathode and an anode and a space between two separate rods, but it looks like you're using one rod. Is that correct?
No, that is not correct. Those are actually two separate rods.
Oh, can't even tell. Okay. Oh, does it
Yep.
look like they fused together or there's actually a gap?
No, that's just where I left it off. There's actually a
Oh,
gap there.
oh, okay, all right. Okay, is there,
And
you know,
it's not really, we didn't design that to use rods. We designed that to use a rod and anvil because you've got lineup issues and everything else. But when you use a rod and anvil, it's really simple. You got a way bigger target to hit.
oh, okay. Is that where you're going now with rod and anvil?
That's exactly where I'm going.
Oh, okay, cool. Yeah, because I remember like I think it was Chris Burris from SES was talking about the size of the rod. He was saying that if it was you had to use a 1/4 inch rod, not a 1/2 inch, because you actually get more C60 with the smaller rod. Are you finding that to be true so far, or have you gotten there yet?
I I've not done an analyst yet. I don't have enough to sit to work with. Like I said, this is our very first test burn.
Sure, sure.
But now, what I've noticed, I went back and looked at a lot of patents, and a lot of the stuff from way back uses a 1/4 inch and a 1/2 inch.
Oh, I mean one on one side and the other on the other.
Correct.
Oh, okay. So that'd be kind of like your whole rod and anvil.
Basically, yes.
Yeah, yeah. Okay, that's cool. All right.
And honestly, I'll try it. If it doesn't work that way, then we'll just do it a different way.
Okay. Hey, anyone listening in? Any questions so far for Hank as we go through these photos? Okay, if you do, put it in the chat. Okay, so that's really cool. I love how cooperative and supportive your wife is.
Oh man, dude, she's awesome.
For her to
Poor lady.
my ex would not have even been in the room with that thing. She'd be like, "I'm not going near your contraption." But that's really cool. Okay, all right. Let's just jump back. So now that's the test fire of this chamber, right? Without the
Correct.
water connected in. Okay, all right. So that's what that
Right.
is.
That was actually that wasn't really anything other than just making certain that the concept was going to work. Because
Right.
basically, what we're doing, and I'm going to have to figure out when we go to testing the material that we're able to retrieve. how well it's going to work. We're pretty much welding in reverse.
What do you mean?
Okay, like you said, cathode. I'm sorry. It's really distracting because I'm listening to an echo on a phone right now. All right, you've got positive and negative, okay? You don't want to electrify a metal object with a positive charge that you've got water coming through, right?
Is that explosive?
No, that's just a bad idea because it'll
Oh,
shock the crap out of you.
okay. All right. Good to know. Good to know.
So what we did was we grounded to the body,
Okay.
and the positive is insulated.
Okay.
With me?
Nope.
Okay.
Sorry.
All right, let's put it this way. If you have a cord sitting there and you pick up one or two wires, one or two things is going to happen to you, right?
Yeah, yeah, definitely. If you're grounded, you will. If you're insulated, you're fine.
Exactly. So
Okay.
instead of putting the positive through the body of the Jenny, put the negative through the Jenny,
Oh,
insulate the positive going in,
okay.
and that way, because the carbon soot is ionized when it goes through its plasma event, it will adhere to the outside of the generator.
Okay, so the generator is grounded. Is that correct? In
Yes.
that scenario. Oh, okay, okay, that makes sense.
Right. The
Okay.
body of the Jenny is grounded.
Okay. All right. Oh, okay. Okay, that makes sense. Okay. Cool. So okay, so you're using an arc welder to light this thing up to produce the electricity that goes into and then inside, this is where, I mean, that's where that probe is, right? Basically, you have to go
Uh,
through this hole.
no, they're coming in the sides right now, and that's one of the reasons I
Oh,
love this generator.
okay.
There are actually two different areas that you would be able to do this from. You can do it from side to side, or you can do it from, well, I'm sorry,
So
you do it
that's
horizontally or vertically.
okay. So when we
So,
saw, okay, so this part right here
right.
goes right here.
No,
Oh,
one over.
one over, like right in here or here.
Correct.
Oh,
Right.
okay. All right. Okay.
The one in the middle is a burp valve, so that when you're circulating water through it, you take the plug out of the top and you bleed the water out.
Okay.
That way you don't have any air pockets in there to create steam.
Right. And then inside the actual chamber itself, where the arc is, I mean,
Mhm.
you're filling that up with gas, right?
Yes, absolutely. It would
Where's that port?
take your pick. It can come in either
Oh,
side
okay. So you made it.
horizontally, or it could we can use one of the other ones. There are one, two, three, four. There's five different ports on there.
Okay, so I'm back
There's
up
one on the bottom also.
like this. Okay, so there's these three, and then two on the, or three, three, one on the bottom, and then this guy right here.
Right, and then one on the right side.
Oh, okay. Oh, on this side. Okay. So, okay. All right. Well, what kind of gas are you using?
Well, for this, I haven't used any gas. We went and got. As a matter of fact, that was one of my dad's contributions. I woke up one day and he says, "Come get your helium."
It's hard to get now, isn't it? I heard there's a helium shortage.
Believe it.
Wouldn't you?
Actually, no. It doesn't seem to be quite so hard. The welding shops seem to be in decent supply. We haven't run into that problem.
So helium is the preferred gas, or I thought people were using like argon and other inerts, but helium's the one to go with.
Well,
Is that what you're researching?
I can't speak for them, and I
Okay.
honestly I may not be very well educated on this yet because like I said, I've not done an actual test burn and gotten a yield yet. But from what we had read, apparently helium seems to give a pretty good yield.
All right, hold on. We got someone just joined. Okay, hold on. Just trying to find out who's. Whoever's on, could you mute yourself, please? Okay, there we go. Sorry, I just had to find who was.
Things happen. It's all good.
Okay. All right. So helium.
Yeah. No,
Okay.
my wife just poked me in the ribs and said to mention that the test burn was done without the end caps on it.
Right. Okay. Yeah.
Okay.
Yeah. That's how we can see it, right? So okay. So when you've got this thing lit up, I mean, literally, what, like you said, it's really hot. I mean, this thing right here, when it's firing, what temperature are you hitting? You think?
Honestly, I have no idea. I haven't got. I wanted to test and make sure that the grounding process was going to work correctly, and just be able to give something as our first test burn.
Sure. Oh, that's
And
cool.
wow.
You're seeing it. You're seeing a recording of literally a couple hours ago. That's really cool.
Yes.
History in the making. That is kind of neat. Hey, so what? I mean, let's say just just I'll jump ahead just 1 second here, but how soon
Yeah.
do you think it's going to take before you can actually produce C60 or just like to actually get your first batch and then a silverine foot? I mean, how much more work do you think
Well,
you have to do?
we're crawling right now.
Oh yeah, yeah.
But that was really the first step, because now we just refine what we've done, and then we get the gaskets on this thing, start flooding it with water. We've already made some changes. The rods are gone now. It actually bolts on. The end caps have their own water supply, versus coming off the manifold for the body. So
Uh-huh.
we're just, as we go forward, we're just trying to refine what we're doing.
Sure, sure. So now you basically, so you have the basic build ready, and now it's just
Correct.
tweak and refine. Okay. So there's okay. All right. So
Hmm.
that's skinny. That's skinny, and then this is just your fabrication.
Right.
Um, okay. So let me ask you some questions. Okay, us friends, just check the chat. Okay, no questions yet. Okay. So I've got
Please do.
questions. I got lots of questions. How difficult was it to source parts for this?
Oh, dude, it was a nightmare.
Yeah. I mean, what'd you go through? I mean, like just kind of.
Well, first off, you're going to get zero support because nobody knows what you're doing, and if you try and tell them, they're going to look at you like you're an idiot. Uh,
Because they don't understand what you're asking for, right? Because this is all
no,
new. I mean, no one's
no,
ever
they don't
built
have
one
the
of these.
foggiest clue.
Right.
Uh,
It's not like your
the
local welding
majority.
shop's going to tell you what to do.
Oh man, you should.
I
I
can
wish you could
imagine.
have seen.
Hey, I'm building this arc reactor, and I need they're going to stare at you and like,
The
yeah.
first time I ever took any one of these pieces to a welding shop, I said, "I need you to tack this or tack this." I swear, they look at me and they're like, "And what the hell is this?"
Should
And
we
then you
call
try and
the
explain
FBI
it, and
or
then they
what?
look at you and they're like, "What the hell is this?"
Yeah, exactly. That's funny.
So yeah, you got a lot of really weird looks. Like, I keep on threatening to take this thing and put it in a Pelican case in the back of my car and drive around town until I get pulled over.
That would do it.
Dude, an egg timer on there and a beeping red light, you're good
Yeah, no
to
kidding.
go.
Yeah, so you have every one of these pieces, all of them were fabricated by you and your family and your friends, right? Working as a team.
Basically, yes. Now you can
Like
remember when
where
we
would you?
first started talking about this last year. I told you that I wanted to try and do an off the shelf gig, okay?
Yeah.
And that way anybody can just go buy the parts. You don't have to be a machining master,
Okay. All right.
which obviously I'm not. If you look at my work, uh, well, actually, I'm not a welder. I don't. Yeah. Anyway, so we were able to source the parts that are standard. Dunlap Stainless in North Georgia. No.
Huh. Okay.
Okay. They handle the stainless steel piping in 5, 6, 7, 8 sizes, or I'm sorry, inch sizes. So that was where we were able to source that. Now, outside of that, McMaster Car is your go-to.
And that's just to get all of the different steel pieces, which you
Correct.
then did
That
they customize it for you, or did you
No,
customize it? Oh, okay.
no.
So you could give them the spec, and they'd give you the part for a lot of money.
Right.
Yeah.
You're looking for off-the-shelf stuff, but then you see the problem that I ran into, and the reason that you're not going to make an off-the-shelf part uh, generator is because there are too many parts that have to be modified and changed and welded up and ground down. It's not going to work. Now you can get standard parts to make it out of, but then you're going to have machining, you're going to have welding.
Hmm. Is this the inside of Skinny, or is this the chamber?
No, that
This
was
is yeah.
when I was just pre-fitting all the parts
Oh, okay.
to do tiny.
Oh, okay, yeah. Oh, tiny.
See, it's all nice and shiny there.
Oh, yeah, yeah. No, that's what it doesn't look like the one we've been looking at. Okay,
No,
so okay, yeah. I was thinking, it'd be just a bear to get the parts for this, but you basically have to customize everything, right?
pretty much, yes, you do. And something else too, everybody needs to understand there are different grades of 303 and 304.
Yeah, that's what you were telling me. Could you describe that?
Well, some grades of 303 and 304 are considered machinable. Others simply are not, and that's going to be most of what you're getting out of China. In the U.S., machinable 303 and 304 way easier to work with. And by the way, like for the lathe bits for this, $10 a piece. These things are actually the exact same carbide bits that you're going to be using for stainless steel up to titanium.
Okay. But all of this is steel, right?
Correct. Every bit of it is stainless.
Okay. All right. Cool. So you had to go around and get all your parts, customize everything, and
Mhm.
you created your own design, right? I mean, you kind of figured it out as you went, based on
Well,
what
like I
the
said, we
studies
based
you
it
read.
off of the naval research,
Okay. All right.
but as we went, we just saw a better way to do this and a better way to do that, and it seems
Uh-huh.
to have worked out pretty well.
Okay. Can you touch on like what would you say, so far? What was like the biggest challenge? I other than you found out your welder wasn't working well and you had to give up on Tiny. What's been the biggest challenge to putting this thing together? Just finding parts, finding experience, finding what would you say?
Well, there is no go-to on any of this. So I mean, like with Martin and with what we're trying to do here, it's really fortunate that people, I mean, nobody discusses this stuff. Anybody that knows what they're talking about, generally, they're too busy burning carbon. They don't have time to talk about it.
Yeah.
Uh,
Well, I think this
information,
webinar will be the first one on YouTube that even talks about this stuff because I've looked high and low, and this
yeah, nobody's
people,
talking, and you can't
universities
really
will have
blame them.
videos about doing test fires and things like that, and but yeah, no one's tried to build one or talk about how to do it. So this is an awesome. Thank you so
Well,
much for your time. This
oh
is
man,
awesome.
no, no. I told you back then. Once we figured this stuff out, we'd be posting
Yeah,
everything that we could.
that's cool.
Uh, Trial and error has been just a nightmare because you try it this way, it doesn't work. You got to try it that way, it doesn't work, and the cost of stainless is so high. Um, Sourcing is really a big problem because you have to deal with lag times. You burn this up, you've got to get a new one. It's going to be 2 weeks till you get it, or it comes in and the part's the wrong size, so you've got to reorder it. That's going to be another 3 days. So it's really a hurry up and wait kind of game.
Right. So how many months are you into it so far?
Well, let's see. It was
Gotcha.
2 weeks before Thanksgiving last year.
Oh, so it's been a year. Yeah. Okay. Yeah. Okay.
Yeah.
Did anything go easy? I mean,
No,
that nothing went easy.
no.
Okay, all you aspiring reactor builders, heed the warning. Okay, so here's my question then. This time,
Hmm?
although you haven't gotten to the point where it's fully assembled and you're producing, because today was the first test fire. But
Correct.
even up to this point in your build, okay, if you had to do it all over again, is there anything you'd do different?
Not do it. I'm serious. I wouldn't do it.
Are you like so far into this that you can't? It's like you're committed. You just have to.
Yep, pretty much.
Oh, I didn't expect that as an answer. Oh, wow. Okay, so you're committed. You've got to finish this thing because money, time, energy, pain, sweat, all that, right? Well, yeah. I mean, the whole world, I think, when they see this, are going to go, "Hey, we want you to finish it. We would love to see C60 produced out of this generator." I think that that'll be fascinating. That's cool.
Well, I'm really. I mean, if we can't do it, then we'll just build another one.
Yeah. So your wife did hear that? Just you say that. um,
Yeah, she just quit glaring and started laughing when you said that.
so okay. So when this thing is up and running in a few months, okay, what do you expect to get out of it? I mean, Martin just said he's getting a 13% yield. What do you expect?
That's an excellent question. Once we start getting dialed in, we're expecting somewhere between about an 11 to 13%. So actually, Martin's pushing the upper levels of
Right, because that's what I've
what.
read as well. As 13 is about the peak. Yeah.
Yeah, but we might have a way around there.
Because you can, I mean, because the idea, right, is first you torch the rods and then you produce soot, then you extract the soot and move on. But you
Correct.
can keep torching the same rods up until the point where you don't have rods, right?
Uh, well, I'm sorry. Be more specific with that question because I could interpret that one of two ways.
Okay, well, I was wondering because to me, like there's because I know that you can do multiple runs using the same rods, right? Or that's what I think I read that where if
No, the rod is destroyed.
or the rods are just completely destroyed. So then
Correct.
you have all this fullerene soot. Then I
Right.
also was in the Build Info chat room. By the way, everybody, Telegram chat room for this. Um, in that room, there was this one time there was this discussion about having that soot. Um, basically spray that into the arc reactor and then arc the soot. So, like in other words, a second burn. But is that just was that just talk, or is that something that's possible?
No, that's not really talk, and that's why I wanted you to be very specific about that.
Oh, yeah,
This really fascinates me because there was some clamor, I think about a week or so ago, that somebody had decided that this was quantum,
yeah,
that what were doing was actually quantum physics.
yeah. There's been a lot of quantum talk lately in the chats.
Well, no, that's
Yeah,
okay. Think about what you're doing.
yeah,
You're trying to keep it cool. You're running it under vacuum, and from the research that we've done, that is absolutely correct. If you take carbon and you burn it a second time, you should come back with that same 11 to 13% yield.
yeah. Well, I mean,
So there's
yeah.
something more going on there that we don't really know yet.
Well, what this does, for those of you who haven't read the papers yet, and I think I will make them available to everybody who listens to this. I think it'll be a beneficial thing for humanity. But you're essentially duplicating or replicating the forces of the universe, because if you go out in space, it's full of C60. And that's been
That is
already
correct.
proven by NASA. So,
Yes.
I mean, it's those types of forces. I mean, literally, though at that mega level, pressures, heat, vacuums,
Hmm.
gases, and that's how C60 is created. It's one of the most prevalent molecules out in outer space and on the planet.
Yeah, but obviously not here.
Yeah, not on the planet, not specifically on the planet. I did a video on that. Okay, so all right, that's really okay. So 13%, and then um, so right now, like to run this thing, like I'm wondering from an energy standpoint, for like what is it like? How much electricity do you have to pour into this thing to get how many grams or something? What's the energy consumption for the reactor, or what do you think it's going to be?
That earlier test burn that you saw, it
Yeah.
seems like was 190 or 195 amps at 220 volts.
Wow, 195 amps.
Mhm.
Wow,
But now,
that's hot.
something also to take into consideration, everything that we've seen, when you actually do this, you're exceeding what the metal can take. So
Yeah.
our plan, if you'll recall, we were talking sometime last year, and we were trying to figure out how they were doing something basically as hot as the sun inside metal that can't take but 1500 degrees.
Yeah, that's my next
And we
question.
thought about it for a couple of days. And I came back, I said, the messing element is time. Do you remember?
Yeah, okay, yeah, yeah. So you just do it
So,
like, so you only arc it like a real short period of time, right?
okay, yeah, from everything that we've researched and read on our end, generally it burn, and I mean, I'm sure somebody out there is going to disagree with me, and that's fine. I want to hear it. But what we're getting is that a typical burn is about 3 seconds.
Okay. And it
And
obliterates the graphite rod. I mean, how much, like, well, I guess you haven't found out yet, but I'm just really, I mean, literally, would that obliterate the entire, what is it, 6-inch rods, 6-inch rods or something? Would that be the entire rod would just turn into powder at that point
as
for
much of
three
it as you could
seconds?
get into the
Yeah.
arc.
Yeah. Oh, yeah. Okay.
Now, the reason that those two were glowing
Uh-huh.
in the earlier test burn, they that was really a mistake on my part. I had gotten it too close, and now keep in mind that it does not have an end feed on it yet, and when it does, it's going to meter it in at a specific rate. But optimally, it should not look like that. Only the tip should be hot.
Oh, okay. Oh,
So
okay. Okay.
it's literally vaporizing the end of that rod.
Right. Well, because okay, maybe you can answer a chemistry question, or we have a resident chemist in the room right now, but at
Outstanding.
that temperature, aren't you going to sublimate the carbon into literally vapor? How does it even turn into soot at that temperature? Because, we're talking temperatures, because when I was doing the video about Something. One of my videos. Anyway, I was reading this paper about you can't go too hot, right? Or you'll
Correct.
sublimate the carbon and it you don't turn it into vapor. So, but here you're easily exceeding. I'm sure you're exceeding the sublimation point. So, is it the
No, I'm certain.
gas? I mean, I don't know. I don't know if you read, but does the gas and vacuum, is that what keeps that thing from just or keeps it a solid as opposed to turn it into gas? Anybody know?
I
Just
have some suspicions, but until I actually start seeing real data come back from what this burn did at this temperature and what that burn did at that speed or that amperage, I don't really feel comfortable trying to. I'm a data guy. I want to see numbers.
yeah, no worries. I'm just a curious guy, and I just find everything so damn interesting, and I just want to know. But that's real okay.
It's a
So
curse, isn't it?
yeah, oh God, tell me about it. My whole video channel is all about me wondering about stuff and then tinkering around. Thank God I haven't killed myself yet. Uh, come close. Okay, so
And just so everybody, when I contacted Kay this morning to let him know everything was going great, he says, "Hey, great, you didn't kill yourself last night."
yeah, exactly. I mean, could this thing explode? Because it's just helium, right? I mean that's inert, but I guess the
Well, that was just open atmosphere.
yeah, okay,
But
yeah, yeah.
when I started this, I was all about springs and rods, and I wanted to build this thing so that if there was anything catastrophic that happened in the chamber, that the worst thing would happen and it would go poof and off gas. And I couldn't understand why everybody was bolting these things down. That's the way to go. The spring thing's not going to happen. And
Oh,
think about
okay.
it. I mean, you're burning carbon inside a helium atmosphere, and it's being vacuumed.
So it's gonna expand,
Yeah, yeah.
big time.
What's the worst thing?
The worst thing,
It'll get hot.
yeah, that it gets hot and the seams pop and metal goes flying. No,
Well, yeah, there is that, but hopefully the water jacket's going to be able to keep it a little bit cooler than that.
or you'll have that water turn into steam and then you'll end up being a lobster. But I'm
That
just
is
thinking
why
out
you
loud.
make
I'm
certain that
just
you've got water and no air in there, so you have to burp the air out
okay. Yeah. All right. There you
because you
go.
don't want that steam to get a foothold and start building.
And stand behind the lead shield, right? That would be my
Are you kidding me? I
preference.
was wearing a Kevlar vest when I did that earlier.
Yeah, I don't think a welder's apron's going to be much protection. Oh man. Okay, so you need so just so far it's 195 amps, 220 volts. Arc that puppy, all the different details about it. So is it? Yeah, it's just I know this is a personal thing, but I'm really curious, and I did have a question in the chat. Um, you know, could you share us like what did it cost you so far? I mean, in terms of money. I mean,
Holy
this
crap.
thing looks
Dude, you're
expensive.
trying to get me killed. My wife is sitting right next to me.
Okay, I just don't know we could go there, right? Okay, so your wife, the number is $20. Okay, so it's 20.
Exactly. Yeah.
Yeah, okay, $20 and a whole bunch of
Let's
favors.
just say way more than we had hoped to spend.
Yeah, okay, that's fair. Okay, so whoever asked that question, there's your answer. Okay.
I, I'm sorry. I'm not trying to be evasive. Let's
Oh no, I understand. It's a touchy subject, especially when you
now.
have
How about
big
this? A small
projects and
car.
wives.
Yeah, a small car.
Oh yeah, okay. So you trade your car, get one of these, make some gold, black gold.
Yep.
Texas crude. Remember that? Okay, I'm dating myself. Okay, so overall time to build was you've been working on it for a year, probably another what 6 more months or maybe and of course you've taken breaks in between. So if let's
Yeah.
say I guess my question is if somebody out there is listening to this and as crazy as we are says, oh, I want to do this, how long would it take if they were like just full time on it? What do you
Okay.
think?
Well, if
What's
they
your
start working from scratch, which I would not do, I use everybody else's work. I mean, there's plenty of research out there, and give yourself a leg up. If they really, really planned it out well, and they were really good and had all their labor lined up, I would say somewhere between 3 to 6 months. Honestly, would
wow,
be.
okay. And that's
I mean,
includes all
it's
the
doable.
delays and stuff with parts and you name it. And they got to have a really like, master welder that really understands steel and all that, right?
Yes, no, there when it comes to the welding,
Right.
it needs to be done and done right. And something else too that I did want to mention, weld as little as you have to.
Ah. Oh.
I I, I mean, you're gonna have to do some welding, but anywhere that you can use a machined part instead of a welded part, me personally, I feel like you're gonna be better off.
Okay. Cool. Okay, so then I had this crazy question, but okay, what else can you make with that thing, or does it have just a sole purpose? Is
Right now, we're shooting just for C60, C70. Now, there will be residuals of probably everything from ounce of nanotubes all the way down to like C2, C4.
right, right.
Uh, but that's really what we're focusing on. That's one of those things later when you have larger samples to work with, then we'll start thinking more along those lines.
Okay, all right, cool. Okay, so you mentioned something a little while ago, and I really want to make sure we squeeze this in because you and I have chatted about this, but from the standpoint of, okay, after you, let's say, get this puppy up and running, you're producing fullerene soot. For anyone who's watched my videos, you know there's a whole separate another set of steps, which is I got the soot. Some of it's amorphous carbon, some of it's fullerenes. How do I get the C60 out? I call that extraction.
Right.
So what's your thinking about, where to take that?
All right. I spoke with everybody that participated in this today, and understand I'm just a face guy. It's nobody else wants to talk. There, no, I mean there are people that did things in this that frankly know more than I do about that particular thing. And as far as me actually putting hands on it and doing it, I don't have that much invested. It's just that they're not interested in being on the internet and doing what we're doing. So I'm just kind of being the liaison here. Okay.
Sure.
Uh, what we would really like to approach, and I got the check off to do this morning, is we would like to start looking at standardizing a simple small generator. And we would like to start possibly doing, and now don't nail me down about this, okay? Because there's a long way to go before we
Yeah,
get
yeah.
there.
Oh, clearly. Okay.
But what we would like to do is start doing kits or something along those lines. So the reason we want to do that is because let's say Monty got a wild hair and decided he wanted to have a fullerene generator.
He would probably want to do one.
Well, see, if we did it and we had a very similar machine, then we could compare our data and we could approach it from an open source.
Uh-huh. Okay.
And if Monty and I got together and we discussed this, and Monty burned, say, 20 amps hotter than I did, or say he kept his water temperature 50 degrees cooler than mine, and he got a 1% better yield than I did. With me?
Oh yeah. Start a guild.
Exactly. That's the direction that we want to go in. We want to standardize a machine. And what we're really looking for now is to get to a point that we're doing for real burns, because once we get to that point, anybody that would like to kind of get in this and try and pioneer it, who knows? We may be able to get way above that 13% burn if we all work together. If ours here in Georgia does, I don't know, say 10% on 10 hours, and Monty's does 12% in the same 10 hours, that's 20 man hours. You've only worked 10.
Oh yeah, yeah. Oh, just
You know,
yeah,
you could you
oh,
could live, you could spend the next
yeah.
several years trying to figure out how to make this thing work right and tweak it out. But that's what we're looking at. We want to get in a position where we can share data.
Oh yeah, the value of the learning curve is
Exactly.
tremendous. Absolutely. So you're thinking, are you thinking actually of producing kits or actual product, like generators, so that other tinkerers out there could produce fullerene soot?
Well, okay, and I've got to say this. This is inherently dangerous.
Oh God, yeah, absolutely.
I mean, it's incredibly hot. You're using a welder. It's all going inside a reactor that has water circulating around it. If you make a mistake, it's going to be a bad day. So no, I will not actually build a reactor and sell it to anyone.
Okay, all right.
Now, what we will do is we will build kits, partially assembled kits, something along those lines, we're fine with that, but I don't want the responsibility. I don't want it on me, or we don't want it on us, any of us. You know,
Yeah.
if somebody got hurt with one of these things, I,
Yeah, I
I
hear you.
just, I wouldn't want to carry that around.
So which is more dangerous, the reactor or the wife's reaction if somebody wants to tell their wife they're going to build this in the garage?
I would go with the wife's reaction.
Yeah, that's what I was thinking.
And I just got slapped in the back of the head.
Okay. Okay. So you're okay. So that's going to be down the road for anyone who's interested. You know, obviously that's going to be down the road, but that's really that's a great idea. Now you had another idea though. Going back to my original question that I want to touch on
Hmm.
to make sure it's in the webinar here, which is all right. So let's say we start this guild. By the way, this is ground zero here on all of this. This is so fascinating. I just love this. This is great because you're the first one to try this. So you do this thing right for humanity, create a guild. But then your other idea,
Right?
I really want to make sure you share it. Is what everybody starts having this fullerene soot. Now what? And then what was your next? I just want you to elaborate on that. It's
Absolutely. And
great idea.
we've been discussing this for several months, and I just got to go ahead to really start talking about this today. Um, what we would like to do is to form a guild and create a common lab, so that, let's say you had 4 pounds of fullerene soot, okay? You might not want to actually do the chemical processing on it, which is great. So you would weigh it, you would send it over to the guild's common lab. They would refine it, weigh it when it comes in, refine it, hopefully bottle and package it, and you would just reap the benefits. Plus, you would get the data, and you're going to have to do it that way if you want to share the data, because you've got to process fullerenes and soot from a common machine at a common lab, because otherwise the results would be meaningless.
Yeah. Okay. So that was a great. When you told me that earlier, I was like, wow, that's really smart because you've got all of these guys running Jenny's, producing the fullerene soot, but then you center your expertise. You get like the chemist people, and it all becomes centralized, where all the soot comes into the central processing center, very much
Yep,
like the wool industry, right? All the wool goes into one place, right? So then that team would then process the fullerene into
correct.
C60 and whatever, basically run it through the extraction. So I guess this picture snuck in. I don't know if you want me to show it or not, but so
Oh yeah, no, go
this is
ahead. And
part
you
of your
already know what that
lab.
is.
This is your sock slit extractor. Is that what that is?
Correct. Mhm.
Where is that picture? Whoops. So okay, but obviously are you going to be synthesizing your own once you soot, or is this just this is your test extraction?
No, actually, that was a batch of red Reese's that we
Oh,
were mixing up
I don't know.
for a gentleman that we know that has terminal cancer.
Oh, okay. So definitely not the C60 picture. It just snuck in,
No,
but it's the same concept, right? I mean, you're going to be using
exactly. That's the only reason I put it in there, was just to
as an example.
kind of reaffirm in the extraction process that you'd be running that with, like, what, toluene, hexane, that kind of thing. That might not necessarily be something that a lot of people would want to do.
Yeah, okay, so that would be the focus of the centralized, chem lab. They would
Exactly.
be doing it. Which brings the question, though, is like, would you ever go into sublimation, or are you going to stick with chemical extraction?
I would probably, if me myself, I would probably stick with chemical extraction for now, just because I understand the process.
Hmm. Okay,
But when you go to a centralized lab, that would really depend more
they
on
can
demand.
actually sublimate everything at that point, so that people have an option between chemically treated C60 versus non, right? I mean,
Correct.
okay. All right, because yeah, there's definitely pros and cons, and there is definitely a market for people who don't want chemically treated C60, and then there's a market for people who don't see that as an issue. So yeah, it's definitely everything. It's definitely out there and it's open.
Well,
Uh,
not only that, but you also have to take into consideration the scientific and the uh, just the whole industrial side of it.
yeah, yeah, absolutely. Whole nother conversation. We can do a whole full webinar just on that. Okay, so right now though, so I guess this is going to take a while to build. So whatever you're going to produce in fullerene, so you're going to process yourself, and then at that point, are you actually planning to then distribute the C60 powder, or primarily use it for yourself and family?
Well,
'Cause-
hopefully there would be a
yeah.
surplus.
Oh yeah, yeah, yeah. That's what I was thinking. Okay.
So yeah, we would definitely be interested. As a matter of fact, well, nah, I'm not going to go there just yet.
Okay, but
We'll
I
talk
still get
about
to be
that
your
later.
first customer, right? Remember, that's what we. Okay,
Absolutely,
we
but
agreed
hey,
on
and by the way,
that. I
like I
want to
said a
be. I
year
want to
ago,
historically be the guy that bought the first batch.
but
I want to
like
be
I
like the
told you
guy that
a
put
year
the
ago,
foot
man,
on the moon.
I want the Redneck of the Year award.
Oh yeah, I could do that. It's in the shape of a big Budweiser can, right?
There you go.
Okay, no, that's great. All right, let's see. Looking at my questions here. So yeah, so the whole essential app. So if there happens to be any chem people out there who like the idea, what's the best way or anybody who's interested in a design kit, or, I mean, obviously it's going to take a while, guys, but if anyone's interested, how would they contact you to talk about it more? What's the best way? Just
Right
into the
this
build
minute,
info chat, or
right this minute, I think I would probably be easiest to find there on the chats.
okay,
Um, I'm really bad at like superstructured environments and being responsible and all that crap. So
yeah.
I don't want like 200 emails in the morning.
Okay. Well, okay. So for those of you who are listening to this webinar, just as you know, if you've seen my other videos, we have a C60, Telegram chat group, and that's like a makers guild for people who would like to make their own C60 oil, and
Okay.
then we also have, and this is what Hank actually is an administrator of, and myself, is we also have another chat group. That I haven't ever told anybody about on YouTube, and that is a Telegram, and it's called Build Info. It's just and it's just been a bunch of guys just chatting about how to build, how would you do this, and if you would, and then this about building a reactor. And so we'll put all that in there, and if you want to reach Hank, right, Hank, just go into that
Ab-
Telegram chat room,
Absolutely. Now
post.
that's going to change. We just did a name reserve and we're setting some things up. I will be way more approachable here in the near future, but just for right now, just catch me in the chat group.
Okay, so go to the
Direct
Telegram
messages,
chat. Yep,
fine.
yep, yep. And then, well, I'm going to actually put it in the video. It'll be in the video description, a link to that chat room, and then you can go in there. And if you look at the history of it, you'll see all of our conversations over the last 12 months about this. And there you go, because I know people will be interested once they hear that this is going on. So yeah, and then I guess the next time we will do this is going to be after you produce the soot, and then it's going to be awesome when you actually have some C60. Are you actually going to go for C60? Are you going to put out any C70, or just focus on C60 for now? Because you will have
Well,
like 3% of C70, right, or around there.
yeah, when I was speaking with Pierre last year, he was telling me, and this is one of those things I'm just going to have to find out the hard way, uh, that a lot of the contaminant in C60 is actually C70.
Right, right, yeah, yeah. It's fullerite. That's the
Yes.
term for that. Yeah. Oh yeah, and
So,
there's nothing wrong with fullerite at all. I mean, well, Martin was kind of saying you should take them on alternate days, but from that standpoint, right, the energetic standpoint, but from a standpoint
right.
of like ingesting C70, a little bit of C70 with C60, is not going to make. There's yeah, because I've actually done it, and because originally when I got Martin's C70 product, I was taking it like I take C60 in the morning around 7, and I was doing C70 at around 10, so I was totally mixing it up, and yeah, I'm still alive and talking. So yeah,
Yeah. Well, dude, it's carbon.
yeah, it's just carbon. Okay. Oh, if anybody, I got this other on the list here. Just we are at the top of the hour, so I got to let you go. But I got one more question someone asked was, would you ever provide consulting advice, like actually hired consulting to help other people, just get that whole learning curve thing again, or is this all going to be open sourced and
Well, that's something that we might want to look at in the future. But for right now, there's a lot of support actually in Build Group. I mean, we've had some incredibly deep conversations about all this stuff. So
oh yeah,
I mean, if anybody's got a question, DM me or I will have emails and contact information soon enough. But the resource is already there.
yeah. Okay. Just want to make sure because I'm just anticipating what people are going to ask. But hey, all right, we are at the top of the hour, and Hank, thank you so much. This has just been awesome to hear about your project, to hear where you're at, to actually see it, and actually see the very first test burn that was recorded this morning. So I
Thank you.
just want to say thanks a lot. Great job, by the way. I mean, fantastic.
Really
It's
appreciate it.
remarkable. I mean, really, it is. It's very remarkable what you've accomplished, you and your team. I mean, because I'm one of the other folks, right, that I've done a really deep dive. I've read dozens of papers on how to do this so that I could do the videos that I've done and understand it, and to see, to see actually somebody do it and get to watch the pictures because nobody else wants to share, right? No, I mean, no one's,
No,
I mean, Martin built with his own, but I respect, he doesn't want to go into, so you're, yeah, it's beyond awesome that you're willing to share what you're learning to help others. I think that's just wonderful. So thank you so much for that.
not at all.
All right, so I will not take up any more of everybody's time. It's been a long morning, but so thanks again, and we'll be
Absolutely
talking.
not, man.
Oh,
Okay, really appreciate it, man. We're glad to be here.
okay. Well, thanks again for your time. I do appreciate it. We'll wrap this up, and I'll probably have it up on YouTube tomorrow, and then we'll see what happens from there.
Outstanding.
All right.
Okay,
Well,
you have a great day,
you
man.
too. Thanks a lot. Aloha. Have a good day. All right.